Now, we are really getting into the lesson. Let me remind you of the formula for the EMF induced in the case of an AC generator, which we did in the last lesson. So EMF induced, E was given as NBA omega sine omega t. So this was the EMF induced. I'm not going to use this letter epsilon from now on. I'll just use V. Okay? Instead of this, I'll use V. That's V for voltage. NBAW sine omega t. In a circuit, this won't change. Number of turns on a coil will not change. B also will not change because you have fixed the magnetic field. The magnets are fixed there, okay? And then A, the area of the coil also will not change. And then omega, if you are rotating it at a constant angular velocity, then that also will not change. So you see, these things won't change. What will change is this quantity, sine omega t. As time increases, the time changes, then the sine value will change. And it will take it from this sine value, this function, which changes with time, that can make this either 0 or at a maximum NBAW. Right? If sine omega t is 1, then V will be equal to NBAW. If sine omega t is equal to 0, then clearly this will be 0. So this is the maximum value this can have. So I'll say that this is this NBAW. I'm going to replace it with this symbol Vm. Okay? Is V max, voltage maximum voltage sine omega t. So V. So I can also put V of t, right? Because V voltage at any time is given by this value. If you want to find the voltage at any time, then that is given by Vm sine omega t, where Vm is NBAW, which is also the maximum it can reach. That's a constant. This is a variable, and this is a constant. The maximum for that is a constant. That value cannot change. But the value that you produce, the voltage that you produce of the generator, that can change. That can change from 0 to this value and back to 0 and minus of this value, then back to 0 again. So that can change. This can change, but this cannot change. It's a maximum value. That is decided only by NBA and W. So I want you to understand that. Okay, so how will the graph look like? The graph of this will look something like this. Okay. So this is time t, and this is V of t. This voltage changes with time, that's why we change it like that. Okay. This will be the maximum, right? I'm going to do it for one cycle, so and this value, this peak, that is Vm, and this will be negative Vm. Okay, so that's it. So this is the sine curve. This is how it's going to look. This is how the AC voltage is going to look like. Okay, so what is the symbol I say for the generator, AC generator? That symbol is this. That is V of t. Okay, and this is the output. Let us suppose I connect a resistor across it. I am connecting a resistor across it. And clearly, this will start sending a current through the circuit because now it is closed. It will send a current through it. And what is the value of that current? Well, the value of the current will also change with time. If V is 0, there will be no current. But if V is, say, 1 volt, then there will be some current. And if let's say this is 10 volts, V is 10 volts, then there will be more current. then when it comes back, then the current will reduce. And when it is 0, again there will be no current. And when it is negative, then when the polarity changes, and if it is minus 1 volt, then current will flow in the opposite direction. For this part, if the current was flowing in one direction, because the polarity is changing, previously it was plus minus. Now it is plus here and then minus there. So current will start flowing in the opposite direction. And again, it will reach its peak and then it will also reach its minimum here. Okay. So that graph, let's say first of all, because the current itself is changing with respect to time, I say that I of t is equal to V of t, that is voltage at any point, any time, right? Current at time t is equal to voltage at time t divided by resistance. And what is voltage at any time? That's given by this equation, right? So I of t can be written, I of t can be written as Vm sine omega t by r. This is a constant, this is a constant. Again, that would be sine omega t is what will be changing in this. So that graph will look something like this. So this is I of t, and this is V of t. This is V of t. So I also have I of t here. So the graph will look like this. Okay, so we found voltage, we found the current. What about the power? So at every instant there will be power. So what is that? The power P of t is given by, power is I squared R or V into I. So either way you can do that. You can say that it's equal to voltage at that time t and then current at that time to Vi. I can say this, or I can also say this as I at that time t square into R. I can say this. I can do it either way. If I start doing it, I'll get the same equations. Notice. V of t is Vm sin omega t, and I of t is Vm by R to sin omega t. So that would be Vm squared by R into sin squared omega t. Okay. And if I use this method, we start doing this, this is equal to Vm by R sin omega t the whole square into R. So that would be Vm square by R square sin square omega t into R. So this will cancel. So we will get Vm square sin square omega t by R. So either way you get the same thing. So the power at any point in time t is given by the current at that point in time multiplied by the voltage at that point in time. So that is what we have done here. Okay. So how will that graph look like? The graph, clearly the power graph would look different. You see, this is V in time, so I'm going to multiply, and then it will be something like that. Power graph, this is P of t graph. P of t graph. And here when this is negative, this is also negative. So negative into negative, then I will get positive. So notice that this is going to be like that. Okay, same. That's the power graph. But then you see the voltage graph is like positive and negative. The current graph is also positive and negative. But then the power graph is always positive in this case. In fact, if we strictly follow mathematics, then you see the period of this oscillation is only half by 2, t by 2. This is half of t. So then it repeats, the pattern repeats. So when I get the average value for power, then even if I calculate it only from here to here, it would still be the same value for this part, because that is getting repeated. So if you find it for one cycle, and if you find it for half cycle, it's the same for full cycle and all the other cycles. It will be half, full, and then 1/3 and 2 cycles, and it will go on like this. So it will be a continuous straight line, even if it goes for 1,000 cycles. Okay, because this is here. The value I calculate for this period will be the same as the value I calculate for this period. I am talking about the average power. Okay. Anyway, so this is what it is. So you have instantaneous power. This is what we call as instantaneous power. So this is called PFT, is instant. At that instant, what is the power? So the power is changing. Again, if something is changing, then what are you trying to do? You are trying to find the average of that value. So this is instantaneous power. At every if I want to find the power at a particular instant, then I need to plug in the time here. Then I get the power at that particular instant. When time is, say, 2 seconds, and time is 3 seconds, or 0.1 second. At 0.1 second, what was the power consumed in this circuit? At 2 seconds, what's the power consumed? I can just put in that number and find the value for that. But it's for that particular instant. But what's the average power? Because power is varying. So what's the average power? Then you have to be using the idea that we introduced a short while ago. That is, you find the area of this and then divide it by the x-axis value, then you get average y-axis value. So that is what we'll be using now. But by the way, I want you to remember this. I said average y-axis value. How do you find the average y-axis value? You find the area and divide by the x-axis value, then you will get the average y-axis value. But how do you find the average x-axis value? Just suppose there could be some applications which may require average x-axis value. Then what do? You find the same area, then divide that by the maximum y-axis value, then you get the average x-axis value. So, but we have not done that yet. But I just want you to think along those lines. Let me do it again. So, I said this is average, right? This is average. So, let's say this is a function. And I get the average y-axis value would be, find the area divided by the x-axis value, then it will be the y-axis value. Why? Because the area, this area, the rectangular area, is the same as this. But this is not the only way to do it, right? So I can even, get some area like that. And my area can be like this also. Okay, so in that case, if you find the area and if you divide that by y value, then I will get the average x-axis value. So I'm trying to tell you. But that's material now. We are bothered about only the average y-axis value. So you find the area, divide that by the x-axis value, then you will get the average y-axis value. We'll stick with that now. Let's not worry about this. Okay? Now, but we'll touch upon this later. Much later. Not in this lesson, in another lesson. Anyway, so this is what I've got. Okay, so this is an instantaneous power. Then how do you find the average power? Well, if we've done that, right? Suppose the average power would be like this instantaneous power, okay? Instantaneous power, and then which is integrated over the entire cycle. So that will give me the area, right? The area from 0 to t. If I take this graph and then if I integrate it from here to here, then I'll get this area. I'll get this area. This area is what I'll get if I do this. And if I divide that by total time, the period of this, then I will get the average, or maybe something like this. This is going to be my P average. Okay, so that is exactly what I'm going to do. So my average power P is equal to this divided by this is the area, and divided by the time. So I can use it here. So that is going to be equal to Vm squared by R, which is constant. I can take it out, and then this will be integral 0 to t sine squared omega t by, okay, do this, and after the integration, divided by t. Okay, so we know the value of this. We've just done this. Sine squared omega t integrated from 0 to t divided by t will give you half, 1 by 2. So this value we just calculated this to be 1 by 2. So what I'm going to get now, so the average power P average is equal to Vm squared by 2R. Okay, so this is what you get, and I can also do it slightly differently. So this would be, let me take this, IT is equal to Vm, and take this. So so I of t is given by Vm by R into sine omega t. And I'm going to write this Vm by R as Im, the maximum current possible. So this value, I'm referring to this value basically. What is it? This maximum current, right? So Vm by R will be Im, the maximum current in the circuit. Okay, so this I'm going to replace as maximum current Im sine omega t. Okay. So if I want to use this in this equation, so the average, average power can be given as, this can be written as I squared R, right? So Im squared R. Okay, I will expand it. So I'll say 1 by 2 I'll keep here, and then this is going to be Vm squared by R. So that's what is given. I'm going to multiply this by R and divide it by R. Then I'm going to get R into, this is Vm squared by r square into r. So Vm by r the whole square into r. So P average can also be written as half Im squared r. So note this. P average can be written as Vm squared by 2r, or it can be written as Im squared r by 2. I can write it either way. Both are the same. So we'll continue this discussion. Okay, we now know that the average power is equal to Im squared r by 2. Let me do this. What is I of t? I of t is Im then sine omega t. Okay. Now, I am going to introduce some quantity y. Okay. So this y is equal to I of t squared. Okay. I'll tell you why I am doing it. But right now, this y is equal to I of t whole square. If we define y like this, then this is equal to this Im sine omega t the whole square. So that is going to give me Im square sine square omega t. That's my y. Okay. Okay. So what I'm going to do now is that I'm going to find the average value for this y. If I find the average value for this, you can see that this is also a function which changes with time. So I can find the average value, right? So I can find the average value. Y average is equal to clearly 0 to t Im squared sine squared omega t by t for one cycle. So the constant I can take out. So the constant can come out Im squared. Then I will get 0 to t sine squared omega t dt, that divided by total time. The whole thing divided by time. Okay. This doesn't go in, it is out. You do this first and then you divide it by time. So this this part, this is equal to 1 by 2. So I am saying that y average mean, right, is equal to Im squared by 2. Okay. So what is this basically? Y is equal to I squared. Okay, the average is Im squared by 2. So what is this actually? This is the mean. Okay, this is the mean. What is this? This is the mean of the square of I of t. So the mean of the square of I of t is this. Okay. So now what if I take the root of this? So if I take root of the average, this one, and that is going to be equal to Im by Im squared by the root. So that will give me Im by root 2. So this is called as the root of the mean of the square of So it's the root of the mean of the square of I is this value. So you call this shortly as RMS value of I. RMS value of I. So RMS value of I. This function, current function, is equal to Im by root 2. Okay? So this RMS value of I is Im by root 2. And I need a symbol for this. I'm going to use capital I. So whenever I use capital I mean the RMS value of I, current. So this is equal to Im by root 2. Suppose I take the voltage function. As instead of I of t, I have taken V of t is equal to I Vm sin omega t. And if I did the same thing, then I would have the RMS value of voltage. The RMS value of V of t will be equal to, what would I get? Vm by root 2. It's easy, you can see that. Okay? And that would be capital V. Capital V is equal to Vm by root 2. So this RMS value can be assigned to any quantity that is varying in time. All that you need to do is this. You take that quantity, square that quantity, find the mean of that quantity, and take the square root again. First you are taking it, squaring it, finally you are taking the square root. So you come back to the same thing, except that you have done something in between. You have taken the mean of it and then squaring it. So the RMS value is that. RMS value of any function is this. You take a function, square the function, find the mean, take the square root of the mean. Squared, square root. Just got the mean value. So that if you do this to any function, then you get the RMS value of that function. So the RMS value of current in the circuit is Im by root 2. The RMS value of voltage in the circuit is Vm by root 2. So coming back to this, what have we got there? So I can do this, right? So average power is equal to Im squared R by 2. So I'm going to do it slightly differently. What is Im by root 2? Im by root 2 is this I. So Im squared by 2 will be I squared. Because if I take, I'll do it here. If I take Im by root 2 and if I square it, I'm going to get Im squared by 2, right? So what is this? This is actually I. Im by root 2 is I. So instead of that, Im squared by 2 can be written as capital I, which is now the RMS value. So RMS value of the current in the circuit I into R. You notice that you get something similar to your DC circuit. In the DC circuit, the power was given by I squared. Power was given by I squared R. You got the same thing here in AC. But in the case of AC, which I will you take? Will you take the mean I? No, you can't, because it will be 0. You can't take mean I. You have to take the RMS value of I. So if you take the RMS value of I, this is I squared R. You have to be careful here. What are you calculating here? You are calculating the average power, not the RMS power. Okay, keep that in mind. You are calculating the average power. That is, you take the power function, you find the mean of that. That's all you are doing. The average power is equal to RMSI squared R. This is not average I. Average I in a circuit will be 0. You've seen that. The sin omega t will be 0 over a cycle. So that's not true. So average power is equal to I RMS squared. So this is called as I RMS. Simply I. Capital I means I RMS. The root means square. I to R. Be careful. This is RMS value. This is average value. Two different values. And then now you get something very similar to what you find in a DC. So the average power is equal to I RMS squared multiplied by R. Or if you do a little more manipulation, then you can also get PEV is equal to I into R will be V, right? So it's V RMS into I RMS. So this is not instantaneous value. This is not instantaneous value. It's not instantaneous current. It's not average voltage. It's not average current. Because average voltage will be 0. Average current will be 0. The mean value will be 0. But this is RMS value. And this is also RMS value. So average power is equal to VRMS multiplied by IRMS, or average power is equal to IRMS squared into R. Now you got two equations which are very similar to the ones you had in DC circuits. Hope this is clear to you. So along the same lines, we can say that IRMS is equal to Im by root 2, and then VRMS is equal to Vm by root 2, which means that Vm maximum is equal to root 2 into VRMS. So if they gave you a maximum voltage, then you can find VRMS by dividing it by root 2. Or if they gave you RMS voltage, then you can find V maximum voltage by multiplying them with root 2. The same thing there. So that gives you I max is equal to root 2 into I. And again, V RMS, this is capital V is RMS, is equal to I RMS into resistance R. V is equal to I. You can see that this is again like a DC circuit, and then you also know that power is equal to V into I, or that is also equal to I squared R. In this case, the V and I are all RMS values. This is average power. Careful. This is average power. This is RMS voltage and RMS current. RMS voltage is equal to RMS current multiplied by resistance. So this is how you match AC with DC. Now let's do a problem. Example 7.1. A light bulb is rated at 100 watts for a 220 volt supply. Find the resistance of the bulb, the peak voltage of the source, and the RMS current through the bulb. Okay. See, when you look at an appliance, a fridge or a TV, or anything, you will find two ratings. One is 100 volts, 100 watts, and then 220 volts. Or they can say it is 70 watts and 220 volts. So you have to keep this in mind when you read, when you see things like that. The power is the average power. 100 watts is the average power. And the voltage is RMS voltage. So when somebody says 220 volts, 230 volts or 240 volts power supply, then they don't mean the maximum. It's AC alright, but they don't mean the maximum. They mean the RMS value. So the maximum current could be more than that. The maximum voltage would be more than that, obviously. So when they say 220 volt supply, they mean the RMS value. In real life, when you talk about 220 volts, 230 volt supplies and stuff in AC, which means it is the RMS value. The power is average power. Keep that in mind. Relate it to your heads. Okay. The point is, there is a light bulb rated at 100 watts for a 220 volt supply. Find the resistance of the bulb. Well, that's easy again. Okay. So what is the power? Power is average power, he said. Power is average, it's 100 watts. And voltage is given to be 220 volts. This is always RMS voltage. RMS voltage and average power. It's always RMS. Keep that in mind. Just putting it in brackets. Okay. They wanted to find the resistance of the bulb. What would that be? So we know that power is equal to VI. E is equal to V into I, and I is equal to V by R. So this will be V into V by R. So V squared by R, just like the DC. But here it is RMS. So if you want R, then R is equal to V squared by average power. V squared by power average. That's all. So what is the VRMS? V RMS is 220 square. 220 whole square is divided by average power is 100. So what are you going to get? So 22 would be 44, so 484. So it's going to be 484, 2 zeros divided by 100. And this will cancel. So the resistance is equal to 484 ohms. And that's the resistance of the bulb. This example 6.1. And what is the second part? The second part is the peak voltage of the source. What's the peak voltage? What they say. Okay. So we know this. V is equal to Vm by root 2. This is RMS and this is Vmax by root 2. So what is Vmax then? So Vmax is equal to root 2 to V. So it's like this. They want you to find in this graph time V. They want you to find this value. That is not 220. Okay, that is something else. That is root 2 into V. So what is V? V RMS value is given. The rating on your appliance is RMS value. So for voltage and current, not for power. Power is average. Keep that in mind. So root 2 into this is 220 into 1.414. So that it's going to be 311 volt. So maximum is 311. So it starts from 0, then goes to 311, comes to 0, goes to minus 311, goes to 0 again. So this is how the voltage fluctuates. Okay, this is the oscillation actually. Okay, so this is 311 volts. When the peak value is 311, then the VRMS value will be 220. So we'll have VRMS somewhere around 220. So this will be 220. Okay. This is what is mentioned on the appliance. But then the appliance will experience this voltage. So it is 311 volts. Now the third part is the RMS current through the bulb. That's easy again, right? So RMS current through the bulb. You can see P average is equal to V into I. So P average is equal to V times I. Both are RMS values, voltage and current. So I RMS is equal to P average by voltage RMS. P average is 100 watts divided by voltage RMS is 220 volts. So this is going to give you about 0.454 ampere current. So 0.454 ampere current is what is going to flow through that. Again, this is simply the RMS value. Then the maximum value of current, that cannot be found, it's not given. So I is equal to Im by root 2. So that gives you Im is equal to root 2 into I. So that would be 1.414 into I RMS is 0.454. So you multiply this, then you get the I max. So the maximum value of current you will get in the circuit. So much current will flow as a maximum value, and then it will decrease and do that. So that is what will happen in the circuit. Hope this is clear to you.